And good morning. It's day 3. Well, it's actually, day 3 of our video experiment. This is the osmosis and diffusion of an egg. So let's review. We've covered the terms of diffusion. It's the movement of any substance or molecule from a high to a low concentration. We've also been talking about osmosis, which is primarily what this egg lab is working on. That's the movement of water from high to low concentrations. And then we've been talking about isotonic, hypotonic, and hypertonic solutions, which isotonic is when everything is in balance, hypotonic is when there's less of a concentration of molecules, and hypertonic is when you have more of a concentration. And so on our original lab number 1, we got the original mass of the cup, the original mass of the egg and the cup together, and then we determined that our egg started out at 63.8 grams. And then come to find out yesterday, after it had sat 24 hours in vinegar, that our mass had increased to 90.5 grams, which meant we had a net increase of 26.7 grams. So then what we did with our egg was we put it in distilled water. And so I have distilled water still around it. We're now going to pour that water off. So let me put the paper out of the way so we don't get it wet. We're going to pour the water off just like that. There's our egg this morning. And the egg has a nice bright color. Now, yesterday we still have this hard spot on the egg. I don't know if you can see that very well, but we have this nice hard spot where the shell never really did get off. Yesterday in several classes I put our eggs for each class up in front of our projector and candled the egg. That's a process called candling when you put it in front of a bright light. Now, usually you would see any kind of mass inside the egg. In industry, it's used for blood spots, or if you have an embryonic chicken in there, you don't want to sell an embryonic chicken at your neighborhood market. And my theory, because I've never done this experiment before, was that the yolk and the albumin had been liquefied in a reaction with the vinegar, and I think I've stated that. In doing some further research, come to find out the yolk and the albumin, the white part of the egg, should still be intact inside, and then it's just this membrane on the outside that's absorbing the water. So when this laboratory is over, we're going to have an after the lab. You'll want to stay tuned. We're going to have an after the lab segment. I'm going to take these eggs into the teacher's lounge, into our sink, and we're going to drop some of these into the sink. We're going to see how they bounce, if they bounce, and when they do splat, exactly what are they splatting into and what comes out of it. So stay tuned for that. That will be happening next week at the end of our lab, because it's Friday here in Hobbs, America. And so we're going to start this next experiment, and we're going to let it ride the whole weekend and then come back on Monday morning and see what happens. All right. So we have our egg. Now we're still assuming that the cup, Mr. B's science page, we're still assuming that the plastic cup has not absorbed any kind of liquid and its mass has not changed as a result of the experiment, and that any change is happening solely in the egg. And we still have this outer layer. This is what was left of the shell. It appears to be a kind of an even color. I'm going to put it back in the cup, and we're now going to remass this. Theoretically, this is what we are supposed to be working on, and I'll draw this out for people in a separate there's going to be another separate segment called Explaining the Lab. So stay tuned for that one. So we're going to end up with, what are we going to end up with? We're going to end up with 4 or 5 parts to this lab, so just stay tuned. Okay, so I've got the triple beam balance. You're familiar with our triple beam balance here. And we're going to set that on. And as you can see, definitely more mass. Let me go back to what I was explaining. So in the vinegar that we used, the vinegar was 95% water and 5% acid. The acid took care of the shell. Then, because the interior of the egg is quite a bit of water, but it still absorbed more water molecules into the membrane because the membrane was in a hypotonic state. This is what is called an isotonic state because there was a balance between the water on the outside and the water inside. By putting it in pure 100% water molecules, the theory is that we will increase our mass a couple of grams because of just the difference between the vinegar and then the distilled water. So we're going to set this at, see, it was 90.5. So we're going to run that out to 90.5. And nothing's happening. So definitely we have increased in mass. So let me run this up here to 100. Ooh. We've increased quite a bit. I thought 1 or 2 grams would be the increase, and we're going to be more than that because we're at 100. Let me run this to 110. Definitely more than what we need. So let's start running our ones out here. And there's 103. It's starting to come down. 104. Let's see. 104, not quite. Not quite. Let's run that out to 104.5. And now let's let it balance here. I was hypothesizing in class in front of the students that we might see a 1 or 2 gram increase in our mass, but actually we're seeing quite a significant increase in our mass. So, excuse me. All right, so let's record some data here. So as we go down on our table, the mass, the original mass that we started at was 63.8. When we added the vinegar, we were able to increase it to 90.5, which is where we start theoretically here. According to our scale, we're setting at 104.5 grams. That is quite a significant increase. So 104.5 minus 90.5. Yes, I know there's some of you already shouting at me. It's 14. I get it. I know. 0, 4, 10 minus 9 is 1. So that is a 14 gram increase just because the vinegar was 95% water and the distilled water was 100% water. Just think of that. Only a 5% change in the amount of water molecules available, but yet we had a 14 gram increase. So now, the change in the original, this is the change over the original, so 14 over 90.5, and we're being consistent here. Yes, I know there's a couple of you out there yelling, that's the egg and the cup, it's the egg and the cup. I get it. We're going to go ahead and do this to be consistent. We can always go back and find our original mass. And we're even off on this one because on this one we should have subtracted the amount of the egg out. So this math is off by the weight of the cup, which is 8.7 grams. So that's thrown this one off. So that's my mistake there. And you know, as I tell my students, it is okay to make a mistake. Mistakes are how we learn stuff. And I'll go back here and correct this in just a second. But mistakes also tell us that you're trying to do what you're supposed to do. If you just turn in a blank page, or if you just copy, you know, and sometimes teachers can't tell if you've copied or not. But if you copy, the only person that you're letting down is yourself. All right, so end of sermon this morning. So we're going to take 14 and we're going to divide it by 90.5. So here's my calculator. Let me clear that. 14 divided by 90.5 is 15.15469, or 0.154. I know we could run it out here to the 6/9. That would be a 5, and that would make that a 6. We're just going to leave it right here. So that is a 0.15, or a 15% increase. And that's based on only a 5% difference in the water molecules between the vinegar and the distilled water. Now let me go back up here and check this. Let me take this 63.8 out, and we'll start with the mass here of the cup and the egg, since we're using it as a unit. And that was 72.5 to 90.5. So let me just do a couple of changes here. 90.5 minus 72.5 is 18. So not quite the significant increase that we thought. 18 grams changed. So now, let me draw a line through that, X that out. So now we have 18 divided by 90.5. So 18 divided by 90.5 gives us a 20% increase. And that's a positive change right there. So, and when I see papers like this, it tells me students are working. I have absolutely no problem with that. So for today, we've still increased. We've had a total of about a 35% increase over the beginning mass at 72.5. We're up to 104.5. Now the next part asks us to put syrup in, and in a lot of them it says Karo syrup. We're going to use just good old-fashioned Mrs. Butterworth's, and the main ingredient in Mrs. Butterworth's, the first ingredient, is high fructose corn syrup, which is the same as Karo syrup, or Karo syrup traditionally was just a corn syrup. So the third ingredient in here is water. This is less expensive than buying Karo syrup, believe it or not. So we're going to use Mrs. Butterworth's. This is all I've got for the day. I've got 6 classes to do plus the video that we're doing. So what I will end up doing with some classes is I will be making a saltwater mixture. And we'll put the eggs in a saltwater mixture and see how that goes. And I'll even bring in some sugar, and we'll do a sugar water mixture. We'll just make up a simple syrup and try that in several different classes today and see how that works. So we're going to take our egg, and somebody's been really messy with this, and we're just going to cover the, oh, doesn't that just look delicious? Oh yes. We're going to cover the egg in syrup. The idea here is that the syrup is a hypotonic solution. It has a lower concentration of water molecules than inside the egg. We have been stuffing this egg with water molecules now for the past 2 days. And what we're going to do now is we're going to put it in a hypotonic solution. Theoretically, what should happen is, because there's less water molecules in the syrup, the water molecules that are inside the egg will move out into the syrup, and that our egg should actually decrease in mass when we remass it again on Monday. So, will it? Maybe the sugars will be drawn in to where the water is. Some students might think that. We will see. But spoiler alert, the plan is that the syrup will draw water molecules out, and that at the end of this experiment, this egg will have less mass than it does right now. Will it go back to the original 63? I don't know. We'll find out. Never done this one before. Can't tell you what's going to happen, but I can tell you that there will be an explanation video with some drawings, and there's going to be an after the lab, because I want to see if there's actually a yolk and an albumin, or the white, still inside that egg. Plus, I know all of you are going to want to know, because it feels like a rubber ball, that is it going to bounce? So we'll find out on Monday. And then one final note before I wrap this up. I had a student in class yesterday that wanted to touch the egg in the class. Remember, it had been setting, in our class ones had been setting in vinegar for 48 hours for 2 days. Had a student that reached out and touched the egg and then immediately said, I need to go to the nurse because I have salmonella. And stopped the class and explained to the class that salmonella is a bacteria. Salmonella is most generally associated with eggs and egg products like mayonnaise or potato salad or macaroni salad, anything that's made with eggs, whipped eggs. Salmonella loves growing in an egg medium. It loves eggs for food. And if you leave your food out and you let it come to room temperature and it has a chance to set for a while, the salmonella bacteria will grow and flourish. And if you eat that, then it invades your body, invades your gut, and in many cases people get very sick, stomach cramps, diarrhea, and in some severe cases people die. I told the student yesterday that this thing had been setting in vinegar and acid solution for 2 days. It was highly unlikely that any salmonella bacteria were living on the surface of this egg. Now, had any student cracked the egg open and squeezed the egg and broke the egg and we had the yolk and the white running around, very definitely I would have had the student wash their hands, go visit the nurse. We would have filed a report that something had happened and there was a possibility of future infection. Basic common sense hygiene. I've handled these now 7 or 8 times in front of classes and for the video. After each one, I wipe my hands with a Clorox wipe. I then go in and go to our teacher's lounge. I wash my hands in a soap and water. I'm just taking care of basic hygiene. Keep my fingers out of my mouth. Don't touch anything else, that I don't have to, and just observe basic common sense. Told the student right in front of everybody that I'm not going to play the game. If you really need to go to the nurse, there's the pass. Let's go. So, end of that. And here we are, end of day 3. It's got some syrup on it. We will now see what happens. Enjoy.